Hello everyone and welcome to a new series on this channel. We are going to be going over networking, computer networking. How does it work? We're going to be talking about the first few layers to networking. If you do have any questions, please leave them in the comments below as we continue to go on. I do ask that you please leave them in the video that they are most applicable to. That way there's some context for the questions given, if I were to go back through and review. The topics that we're going to cover in this series are the first few layers in the OSI 5-layer or TCP/IP networking model. We'll be going over those models here to begin with, but we'll take a peek at what we're going through. We'll do a quick little overview. We'll discuss some networking layers, networking models. We'll be going over physical connections. We'll be going over data links, addressing and routing, and we'll be finishing it off with ports and protocols. Well, let's begin with the big question. What is networking? Well, Amazon Web Services defines computer networking as this. Computer networking refers to interconnected computing devices that can exchange data and share resources with each other. I'm going to cross off a few words there and we're going to come up with a new definition. There's some crossed off words and we'll sum it up to connected computing devices exchanging data with each other. What are the key networking components? What do we need for networking? Well, through that definition, we came up with a few items. We need a connection. Could be cable, could be wireless, but we need a connection. We need a computing device. Actually, we need multiple. These are often referred to as hosts or nodes. Could be any kind of a computer, printer, something like that. Router. We need a device that computes. Well, the most important step, we need data. We need something to actually go between the devices, the nodes. Finally, we need a method of exchange. We need to actually get a way to get the data across. I'm going to go through a few very simple just definitions here. Let's define host node, data, physical, logical, MAC address, and IP address. Starting off, a host or a node is any end device. End is a little bit vague in there. It could just be any device attached to a network. We might have what's called a router or a switch. Technically, it is a node on that network. It might not be directly an end device. However, it is attached to a network, and it is still a device, and it still can send or receive data, so it can be at the end of any data transmissions. We need data. Data is any information sent to or from a host. Definition for physical in this case is an actual connection or actual hardware, something actual, tangible, physical. Logical is a virtual interaction. It's not necessarily a physical cable. It might just be the way that those devices function at a virtual or configuration level. MAC address is a hardware assigned identifier. An IP address is a unique logical identifier. Again, logical is a virtual identifier, whereas a MAC address is a hardware assigned or a physical identifier. Let's take a peek at a couple networking models. A networking model is a diagram of a process or a data flow. The three most popular networking models are the OSI model, the TCP/IP model, and the TCP 5-layer model, often just called the 5-layer model. We're going to start off with the most in-depth, which is the OSI model. It is a 7-layer model. Starting off at the very, very bottom of that, we have the physical layer. Physical layer is the cabling layer. It's, fiber, it's repeaters, it's your actual cabling. It's what actually physically connects devices. The next layer up, layer 2 on this model, is called the data link layer. It's node communication. It's actually the negotiation of communication, the core fundamental level of communication. That third layer is the network layer. It's where we get IP addresses into play. It's where routing happens. It's where stuff actually gets places between multiple networks or just on a single network. Fourth layer is the transport layer, the actual transmission or receiving of the data from different nodes. Session layer is the connection layer. This is where we start to get into applications, into actual programs versus networking, and how the data is actually interacted with once it reaches a node. Again, this presentation is going to cover the transport, network, data link, and the physical layers. Session, presentation, and application functions a little bit more on the actual software developer point of view versus a network engineering point of view. Again, sessions, the connection layer, it is inside an application, it is inside a program, and it does usually function at more of a systems or software engineer side versus a networking side. The presentation layer is syntax. It's actually assembling data and getting it into a way where it's readable by the application layer, which is the end user layer. It's where data that has been transmitted is actually existing now. The next model that we're going to look at is the TCP/IP model. You'll see it's similar. They do combine those top 3 layers into a general application layer. Kind of nice to have those kind of just almost out of the mind as the application layer. I do personally prefer to use the OSI model with the 7 layers because it is helpful for troubleshooting to look at each item individually. I'm not a big fan on the TCP/IP model, how it combines the physical and the data link layer. I do believe that there's enough differences between the actual cabling versus the communication over that cabling to separate them. However, the general layout for this model is the same. Final layer that we're going to be looking at is the 5-layer model, which is a hybrid of the two. We see that the application layer still combines those top 3 layers, but the physical and the data link layer are now separate. Very useful model for just networking. If your core focus, sole focus is networking, this is really the data that you need to know is on this 5-layer model. However, if you want to be good at, a little bit all things, kind of understand how data flows after it just kind of gets out of that third-party network and actually how it gets processed on that end device or node, I do recommend utilizing the OSI model. Well, that takes us back to our outline, and we have completed our overview, ending episode 1 of this series. Again, there will be a link in the description to a playlist with every episode in this series as it comes out. Feel free to leave any questions in the comments to the applicable video. There is a Discord in this description as well. Feel free to join if there's any questions, anything that you're trying to figure out. I will see you in the next episode where we will start discussing physical connections.